Today we will learn about the first order system. Previous class I has discussed the equation of first order system. The most general form of differential equation represented a first order system. The first order system can be expressed as the mathematical form is tau into dy by dt plus yt is equal to k into x within bracket and t. It is the differential first order equation where y within bracket t and x within bracket t are output and input variable. Output and input variable. Put output variable and the coefficient tau and k and the coefficient and the coefficient tau and k are called the time constant and steady state gain are called the time constant and steady state gain. Here tau is called the time constant and k is called the steady state gain. Let in bracket x within t and y within bracket t are the input output variable of the system respectively are the input output variable respect respectively the transfer function of the system. The transfer function of the system describe the above equation described the above equation. Taking the Laplace transform on both sides, the initial the assuming condition is 0. This is the equation first order and the system. The will take the Laplace, then their form will be this is the ys is the output, x within bracket s is the input is equal to K by tau S plus 1. It is the Laplace transform of first order equation. Let's take a example for clear a confusion. We'll take the RC circuit. Here the resistance, the output is connected through the capacitor. This is the resistance. This is the capacitor. Output voltage V0 bracket T. Here the input voltage in bracket T. It is a RC. It is a RC circuit. They apply the KVL on the circuit. Applying the KVL to the circuit, then we get here the input voltage V suffix I within bracket and T is equal to resistance voltage R within bracket T plus capacitive voltage 1 by C into integration infinity to time T I dt. It is the equation of our circuit, and their output voltage means capacitive voltage V suffix 0 within bracket T is equal to 1 by C integration of constant infinity to T in I dt. It is the output voltage. This is the equation 1. This is the equation 2. Applying the Laplace transform on both sides. Applying the Laplace transform on both sides of equation 1. There the equation is to the transform of Laplace, the capital S is equal to R I S plus 1 by CS into I S. This is equation number 3. It is the transform of it is the transformation equation of equation 1. It is the this form of after the Laplace transform. Laplace transform, we will find out the current of the circuit. Then the current I bracket IS is equal to input voltage I S by into CS by RC S plus 1 RCS plus 1. Next is the apply the Laplace transform. Applying the Laplace transform. Applying the Laplace transform in both sides of the equation 2. Equation 2 is the output voltage of the circuit. The output voltage V0 within bracket S is equal to Is by Cs. It is the transformation of equation 1. It is the equation number 4. The next step is the substituting the equation 2. The substituting the equation in the equation in the equation is substituting the equation number 3 and 4. So number 3 and 4. The third equation I is equal to input voltage Vi into S within SCS by RCS plus 1. Then RCS is equal to, we know that V0 CS is equal to BIS into CS by RCS plus 1. Here the CS and the CS at the both sides CS will be cancelled. Then the equation will be here the put PS V0S is equal to V1S by RCS plus 1. We will find out the ratio of output to input. The 0S by V1 is equal to is equal to 1 by RCS plus 1. CS plus 1. Here the similar in case of RC circuit, note that the input voltage is Vi, the output voltage is V0. Here the gain is equal to, here the gain is K is equal to 1 and the time constant and the time constant RC is equal to T. The tau is equal to RC, the time constant. And from the above discussion, we may notice that any first order system can be represented by the transfer function. If we know that the time constant tau and steady state gain K of the system, that is and the G is equal to K by tau S plus 1, and the given electrical system K is equal to 1 and tau is equal to RC respectively. It is the equation of first order system or the equivalent equation of RC circuit. Here the GS, we know that the GS is equal to output by input. Here the output voltage by input voltage equal to GS. GS is a transfer function. One is equivalent to the steady state gain. We know that the steady gain is K is equal to 1, and we know that the RC is equal to time constant of RC circuit. The RC is equal to tau. Here the put the value of RC is T into S plus 1. It is the first order equation of of transfer function, or it is the transfer function of RC circuit.